So our learning intention today is solving quadratic inequalities. Our National 5 essential skills are that we need to be able to factorise, completing the square and sketching quadratics. Let's get started. So our prior knowledge, a quadratic equation can be solved by factorising. The solutions are the roots of the function. That's where it cuts the x-axis. This information can be used to sketch the function by determining the axis of symmetry, position and nature of the turning point. A quadratic inequation can be solved by inspecting a sketch of the function. Let's try an example. Example 1. We're going to solve x squared plus 3x minus 4 equal to 0. Then from that solution we can then work out x squared plus 3x minus 4 less than 0 and also greater than 0. So start with the basic one part. So x squared plus 3x minus 4 equals to 0 is just solving a quadratic, so we factorise it. So we'll get x plus 4, x minus 1 equals to 0. The solutions to that equation are therefore x equals minus 4 and x equals 1. So the solutions of a quadratic are the roots of the function. It's where they cut the x-axis. Looking back at the first equation, the coefficient of x squared is 1. So a is 1, it's positive, it's going to give me a minimum turning point. Other information we have there is that c equals minus 4. That's the y-intercept, is going to be 0, negative 4. So it's cutting below the x-axis. That information can help us sketch the graph. And here's a sketch for you. I've plotted the roots, x equals minus 4, x is 1. And I've got the y-intercept 0, negative 4. Now in the past we've also looked at the axis of symmetry, but we don't have to do that today. A quick sketch is going to help us then solve parts B and C. So for part B, x squared plus 3x minus 4 is less than 0. Where is the function negative? Now the function is negative where the curve goes below the x-axis. So that's when x is going to be greater than minus 4 but less than 1. And that's shown by the shaded area on the graph. For part C then, we're looking for x squared plus 3x minus 4 greater than 0. That means the function is positive. So where's the function positive? It's where the graph goes above the x-axis. So it goes above the x-axis when x is less than minus 4, shown by the shaded area, but also where x is greater than 1 and 1's the other root there, shown by that shaded area. Right, time for another example then. Example 2. Solve the quadratic inequality 12 minus 5x minus 2x squared less than 0. So suddenly we've jumped up here and it's getting a lot harder. This is a higher level. So start off with 12 minus 5x minus 2x squared equals to 0. We're going to solve it and sketch it to help us solve this problem. Now it's easier to just write it backwards. Minus 2x squared minus 5x plus 2 equals 0. I take the minus 1 out to help me factorise it. So take the minus 1 out as a common factor. And inside the bracket I've now got 2x squared plus 5x, now it's changed sign, minus 12x, it's changed sign as well, equal to 0. I leave the negative out and I factorise it. I've got 2x minus 3, x plus 4. Now take the time to make sure you fully understand how that's factorised. I can now solve it, and I've got the roots are x equals 3 over 2 and x equals minus 4. Now a equals minus 2 means that it's negative, so I've got a maximum turning point I'm expecting. And from the original function, c equals 12, so that's telling me the y-intercept is 0, 12. So using all this information, I can draw a quick sketch. This sketch is showing a maximum turning point, it's cutting at 0, 12, and it has the roots minus 4 and 1.5, 3 over 2. Now that's me not solved the problem, because the problem wasn't asking me for a sketch, it was asking me to determine where this function is greater or equal to 0. Now it's equal to 0, on its roots, but what about greater than 0? So it's greater than 0, that line goes above the x-axis as shown by the shaded area. So what are the values for x? The values for x must be greater or equal to -4, but less than or equal to 1.5, 3 over 2. So take time to copy this down into your notes. You can remember to pause me at any point in time. Right, ready to move on then? Try these examples on your own. Solve the following inequalities. X squared minus x minus 6 greater than 0. 2x squared plus 11x plus 5 less than or equal to 0. And 8 plus 2x minus x squared greater than 0. So follow the steps. Solve the function equal to 0. Make a sketch. If you're looking for the function greater than 0, it's positive, it's above the x-axis. If you're looking for the function less than 0, it's negative, it's below the x-axis. So take time to pause, try this in your classwork jotter, and then come back when you're ready to see the answers. Right, here's the answers for you. Okay, look over them carefully, check your answers as well. Okay, if you've not got my answer, look back, can you find your mistakes, what's gone wrong? So take the time please to check back over your work. If you're really stuck, come and see me in class and I'll explain it to you. It's not a problem. Once you've finished marking your work, remember the next thing to do is assess your progress. How did you feel about this topic? Now it is going to be difficult because it's a higher level work, but can you figure out what parts you're finding tricky? Then we can work on it. So here's your status. Self-assess your progress. Red, amber or green. So what we learned today? We've learned how to solve quadratic inequalities by following the following steps. Solve the equation equal to 0. Sketch it. If you're trying to solve an equation greater than 0, then you're looking for values above the x-axis. Where does the quadratic go above the x-axis? Greater than equal to is above and including the roots. Less than 0, it's negative, it's below the x-axis, but remember less than or equal to is below and including the roots, so be very careful with your notation. That's us finished for today. See you in class.